back. Let us look at another example of evaluating integrals for a challenging problem. So guys, as you can already see that there is a combination of the trig functions and the exponential functions, and there's also a ratio like this. So obviously we cannot use any direct methods of evaluating this integral. So guys, there's few things one can do here. One of the things that one can do here is like try to break it down, and then one may have to use some trig identities, and then we can go from there. Okay, so we may not have like a direct starting step here, but at least we can see that we can break this down or use some trig identities to just get started. So guys, as I mentioned earlier as well in my other videos, sometimes we may not really know exactly what to do in order to actually evaluate this integral, but if we have some sense of like, okay, we can simplify this way or that way, so we have to give it a try. So in this case, again, we are going to give it a try and then see what we can do from there. So the first step, what I'm going to do here is I'm going to rewrite this as, so this can be broken down as 2 over 1 plus cosine 2x, right? Because this has to be divided by the denominator, and then I'm breaking this down as plus sine 2x over 1 plus cosine 2x. So that is my first step, that I'm trying to break this down because there's no other way of really trying to evaluate this. So that's why I decided to break down. And then of course there's an e to the x right here, and then dx. Okay, so still it looks really complex and complicated, but what I'm going to do here is, guys, I am going to try to write the identities for the cosine 2x and sine 2x. And what identities I'm talking about? The identities are the double angle identities for sine and cosine. So guys, if you remember those, that's great. If not, then please go back and look at the double angle identities from a formula sheet. Now the double angle identities are like this. So for 1 plus cosine, so it's going to be 1 plus cosine 2x. Guys, cosine 2x is, there's few ways of writing cosine 2x. One of the ways is to write it as 2 cosine square x minus 1. I'm going to use that. Why I'm using this one? Because I see there's a positive 1 here. So if I break it as, or if I rewrite this as this minus 1, then I'm guaranteed that 1 and positive 1 and negative 1 will cross out. So I'm thinking of trying to simplify this or condense this this function. Okay, that is this guy, and then there is plus sine 2x. We know sine 2x can be written as 2 sine x cosine x. Guys, these are trig identities that one has to remember, or one has to use a formula sheet for that. Downstairs, I'm going to do the same thing that I did here, because again, I feel like I want to get rid of that positive 1. So it's going to be 1 plus 2 cosine square x minus 1. And then close the parentheses, there's an e to the x dx. Let us see what happens now when we try to simplify things. Integral, there's going to be a 2 upstairs, and then downstairs 1 and negative 1 crosses out. I'll be left with 2 cosine square x, right? And eventually this 2 and 2 will also cross out, but let us try to do things in steps. Guys, up here on this side, it will be 2 sine x cosine x, and divided by, again, 1 and 1 will cross out, it's just 2 cosine square x. So I'll try to write all the steps. And then what do I have? I have e to the x dx. So guys, this is the form broken down. And now let us see if we simplify more, and let's see how this is going to help us to actually evaluate the integral. Okay, so I'll get rid of this. I definitely need a lot more space to actually evaluate this whole integral. So let us get rid of this and see what we can do with this, these two forms here. So from here, I'm going back right here. So it's same as integral. Guys, 2's will cross out, and it's going to be 1 over cosine square x, right? And then plus, guys, here the 2's will cross out as well, and then I can already cross out one of the cosines and cosines, because there's a cosine square downstairs and just a cosine x. So the one of the cosines will cross out, and 2's will cross out. So I will be left with just sine x over cosine x, right? Because we want to simplify if we can, and that's why we try to like use trig identity, so that we can just simplify this into something smaller or something that we can evaluate the integral for. I mean, we still may not be able to see like whether we can evaluate the integrals, guys, but one has to try to simplify and then see later if we can actually evaluate the integrals. So just hold on to like just these steps and see what is going to happen. Here we have this, okay. Now guys, what we can do here is 1 over cosine square x. Again, 1 over cosine square x, we know we have to use a trig identity here, is the secant square x, because cosine and secant are reciprocals of each other. And then we know sine over cosine is also a trig identity, and sine over cosine is the tangent of x. And then there's this e to the x dx, right? So what I'm going to do from here is, guys, I'm going to distribute that e to the x with both of these terms. So it's going to look like this. E to the x secant square x dx. And then the next term is going to be integral e to the x tangent x dx. Okay, e to the x tangent x dx. Guys, a lot of this comes with experience and practice. And then once you also practice a lot of these problems, then you can also like figure out some of these steps of distributing, multiplying, simplifying. We need more space. Let us see what we can do from here. Okay, guys, from here, it seems like there's a product of two functions here as well as here. How about if we think in terms of using the integration by parts? Because that's usually what we do when we have the product of two functions. And let us give that a try. But and let us first remind ourselves this ILATE thing, which we know like here we're comparing exponential with trig. So trig takes the precedence over the exponential. So this should be my f, this should be my g. And in both the cases, I'm comparing between an exponential and trig function here as well as here. But guys, here is the tricky part here that actually helps us to simplify this very quickly. Otherwise, we'll just be doing integration by parts on both of these and probably just end up just writing steps and not be able to actually evaluate the integrals. Guys, here's something that one has to know and one has to kind of think before one starts using the integration by parts method on both. And that is looking at both of these, and especially looking at this guy right here and thinking through the steps of integration by parts where one has to take the derivative and integrals and all that, right? So guys, here what I'm thinking is that I have to use this as an f and this as an g based on this, right? Same thing here, this as an f and this as an g. But let us not think about this for a second. Let us think about this function right here, because this is simpler. In a way, there's like a tangent function by itself. There's no squaring here, but here there's a squared as well. So this function seems to be a little bit easier or simpler than this one. Now, if I think about this particular function and then I think about this as my f and this as my g, let me already mark that down so we know what we are talking about. This is going to be my f, this is going to be my g, and there's no confusion about it. It's just based on this technique of giving precedence to the trig function before the exponential function. Now from here, when I'm looking at this and I'm thinking about I'm basically visualizing the integration by parts formula. I know like the steps are we have to take the derivative of f and integrate g, right? So what is derivative of f? I already know that the derivative of the tangent function is the secant square x, right? And then the integral or the derivative of e to the x is just the e to the x. That's the nice thing about the exponential function. So what I'm thinking to myself is that if I do the derivative of this, it will give me secant square. I already have a secant square here. And then if I get a negative somehow, and in that integration by parts formula, there's a negative piece as well. Then from there, maybe there's a possibility that one of the terms would be negative and this is already positive and things may cross out. Guys, if you are not able to see that right now, that is fine because it comes with practice and experience, okay? So sometimes you just have to give it a try. And then if it works out well, if it does not, then you have to try something different. So in this case, I'm going to try to just use the integration by parts on just this expression and not on this, okay? And then we'll see what will happen. So using the integration by parts method only on the second piece, I'm just rewriting the first piece, secant square x dx. And using the integration by parts formula on this one, guys, I'm just quickly going to use the formula. I'm not going to write the whole thing. So it's going to be f, which is tangent of x, and then integral of e to the x dx. Okay, I'm just applying the formula. I'm not writing the general form, I'm just applying it. and then I have a minus integral of the f prime, the tangent. What is the integral of tangent? It is, sorry, what is the derivative of tangent? It is secant square x, and then times I need the integral of the e to the x dx, which is the g function, and of course there's a dx. Okay, let us see what we can do moving further. Let us just leave this alone, e to the x secant square x dx. This we can simplify, and we should simplify that. The integral of exponential function is the exponential function. I'll just write e to the x tangent of x. And then guys, let us try to simplify this. Integral, there's a secant square x, then there's an integral of e to the x. Well, integral of e to the x is just e to the x, so it is just going to be e to the x secant square x dx, right? Just this. Now, if you look at these three terms, we can see that this guy and this guy are exactly the same, and the signs are opposite. So what's going to happen? This and this will just simply cross out. And we are finally left with e to the x tan x, and that would be my value for the integral of this function. So the integral for this function, which looked like a very complex function with double angles and all the ratios and all that, guys, is just simply going to be e to the x tangent x, and then there is a plus c with it. Okay, this is the final answer. So guys, this is what makes it challenging. At this step, if I had tried to like do the integration by parts for this as well, I would not be able to even like simplify or solve this problem. Okay, so we have to be a little bit more like clever, or we had to think about these things and see that we should try to evaluate the integral or use the integration by parts for this. From here, I got this term with secant square x e to the x with an opposite sign, and that just crosses out with this term, and I'm only left with e to the x tan x. So guys, that is what makes this problem challenging, and I wanted to share these techniques and these methods with you. Here we have number 4. There's one more to go. I'm going to show you one more challenging problem before we move into something different. Okay, so guys, till then, practice them, have fun with these examples. I will see you next time.